So let's go for next level of understanding of a spin. So today we will first discuss the nature and behavior of Pauli spin matrices, and then we will go for different types of problem. Okay. So obviously the whole this 2 cross 2 matrix is nothing but Pauli spin matrices. So let's try to see what is these all thing and what are the property of that Pauli spin matrices. So let's try to go for Sx operator is nothing but this will be h cut by 2 and we have 0 1 1 0 and sy operator is equal to h cut by 2 we have 0 minus I 0 and we have sz is equal to h cut by 2 1 0 0 minus 1. So these three are my three component which has basically two-dimensional space in along direction of x, along direction of y, and along direction of z. And when we are talking about this particular thing, so we have h cut upon 2 sigma x. This is basically h cut upon 2 sigma y, and this is basically h cut upon 2 sigma z. And what we have these three matrix, a very popular matrix that is identified as Pauli spin matrices for spin half particle. So this is sigma x and this is 0 1 1 0. This is sigma y. You have 0 minus I 0 and we have sigma z. We have 1 0 0 minus 1. So these are three operators or three matrices which is popularly known as Pauli spin matrices. So they are basically Pauli spin matrices. Okay. Now, so these 3 cross 3 matrices are very important matrices. So it has some property. So if you will just try to see, let me write all this property. So first, this Pauli spin matrices are traceless matrix. So they are basically traceless matrix. Traceless matrix. What is meaning of traceless matrix? When you are adding the diagonal term, that will be 0. So that is traceless in nature. So this is your first basic property. And the eigenvalue is either plus 1 and minus 1. So your eigenvalue of these matrices are all sigma x, sigma y, sigma z has eigenvalue plus 1 and minus 1. So this is another important thing. And they all are basically Hermitian in nature. So all are Hermitian matrix. So third, they are Hermitian in nature. As well as they are unitary in nature. So what is unitary matrix? If you will find sigma inverse, you will get sigma, isn't it? So you have unitary matrix and eigenvalue is also plus minus 1. If you will find the determinant, that determinant is also 1. Determinant means magnitude. So that value is equal to also 1. And now let's try to see what are the basic thing about this particular Pauli spin matrices. So sigma x into sigma y is nothing. If you will multiply sigma x to sigma y, what you will get? You will get basically I time sigma z, isn't it? Yes or no? So you can easily multiply sigma x into sigma y. So this is going to multiply this thing. So you have I and again this will multiply. So you have diagonal matrix. हो रहा है ये? एक बार आप चेक कर सकते हो. Yes या no? हो रहा है?
Yes, sir.
Yes. Similarly, you can have sigma y into sigma z is again I z cap sigma z into sigma x is equal to I sigma y. So you have this particular, you can write this particular thing in a term of Levi-Cita tensor also. So this is your x, this is y, this is z. X into y will give you z, and you are just moving in a cyclic coordinate. And when you will move in a opposite direction, then you have minus sign with yourself. Okay, so you have to remember all this thing with this particular character. And most important thing is that these Pauli spin matrices are not going to commute. So they are not going to commute. Okay, so if we are just trying to figure it out, what will be commutation between Pauli spin matrices? So suppose we are just going to figure it out, sigma x and sigma y. What will be commutation between sigma x and sigma y? So if we are talking about sigma x and sigma y, this is equal to what? Sigma x, sigma y minus sigma y, sigma x. I can put sigma x, sigma y from here is equal to I sigma z minus sigma y, sigma x is negative of I sigma z. So what we have? We have basically sigma x, sigma y is equal to 2I sigma z. And similarly, again, we have this all the cyclic property here. So when we will go for cyclic property, you have sigma y, sigma z is equal to 2I sigma x, and same type of thing you can write sigma z and sigma x is equal to 2 times I sigma y. So yes, again you can have this cyclic property, x and y has sigma z. When you will go for anti-clockwise direction, you have negative thing in your number. So when you are talking about commutation of Pauli spin matrices, you have to always remember this is 2 times I and another component you will get. So you are just doing the commutation into x and y for x component and y component, and you are getting basically that is into the z direction. So this is not going to commute. But one of the most important thing about Pauli spin matrices that they are going to anti-commute. So if I am talking about this thing, so this is anti-commute. So if you are talking about anti-commute, you can give some another notation for anti-commutation, sigma x, sigma y. What is anti-commute? You can write sigma x, sigma y plus sigma y, sigma x. And we know this particular thing, this particular value is equal to I times sigma z plus you have minus I times sigma z. So this is nothing but the zero vector or zero matrix. Yes?
बोर्ड ब्लर दिखाई दे रहा है। अब मुझे
I
तो
don't think
दिखाई दे
board
रहा है।
blur होना चाहिए। नहीं, मेरे हिसाब से तो ठीक है। क्लियर है, आप अपना इंटरनेट चेक कर लो एक बार, है ना? या फिर लॉग ऑफ होकर के फिर से लॉग इन कर लो फास्ट अगर करना चाहो तो। ओके, सो दिस इज नॉट ब्लर्ड। चलो, so this is your the Pauli spin matrices is going to be what? Anti-commute. So this is one of the very interesting thing you have find into the Pauli spin matrices. These are another kind of symmetry is there. So we have different type of symmetry. We should understand all these thing. Okay. And if you will go for the SU2 symmetry, special unitary of group of order 2, this Pauli spin matrices will help you. Okay. So that is, I am not including right now into this part. So this is 2 cross 2 matrix. So order of 2, unitary matrix, yes, a special kind of matrix. So it has some basic special kind of property about this Pauli spin matrices. Okay. So these are the basic character of Pauli spin matrices. Okay. And so let's go for some more property of this particular Pauli spin matrices. Okay. So let's try to go for one very important matrix that is n cap dot sigma. This is one of the very important matrix, and we have to talk about this particular matrix, what we are going to find. Okay, so you have basically any unitary direction, which type of matrix is there, and how we can conclude about this particular thing. Okay, let's try to go for next level of analysis of Pauli spin matrices. So today we will just try to understand the different behavior of Pauli spin matrices. Okay, and from tomorrow we will solve different type of problems. और next class जब भी होगी तो चलो. So let's try to go for a one matrix. This is basically, so let me clean my board first. This is very interesting. This is very interesting. And ऐसा क्वेश्चन इस बार आपके गेट के भी एग्जाम में आया था, है ना? तो आप इसे काफी बेटर ढंग से करोगे. ओके, चलो. Let's try to go for operator A. And what is this operator A? This operator A is basically sigma dot n cap. And what is your n cap? N cap is a unit vector. Unit vector in a space. So this is your unit vector in a space. So you can write it unit vector in a space with a Cartesian coordinate, also in a polar coordinate. So we are just using this thing as a, what is unit vector? Any vector whose magnitude is basically 1. So what is my n cap? I can write my n cap as, you have I component, y, I, j and k component. So this is your r sine theta cos phi into I direction plus r sine theta j cap, sorry, r sine theta sine phi j cap direction plus r cos theta. So any vector, and we have to divide it with the mod of this vector. So we can divide with r, the magnitude of this thing. So unit vector in any theta and phi direction, because magnitude is 1, so there is not any relevance of r. So n cap vector in any theta and phi direction is given by sine theta cos phi plus, and this is in I cap direction, that is sine theta sine phi in j cap direction plus we have cos theta in k cap direction. So let's try to, and what is my sigma vector? The sigma vector is basically sigma x I cap, sigma y j cap plus sigma z k cap. Sigma x, sigma y, sigma z are basically Pauli spin matrix. So when you are going to calculate this particular thing, and we just want to find what will be sigma n cap. So this is basically sigma x. So I have to use this space also. Sigma x sine theta cos phi plus sigma y sine theta sine phi plus sigma z cos theta. So if we are going to multiply this number, so this is just of one particular number for given value of theta and phi, we can multiply this thing. So what we will get? We will get this sigma x as 0, and this component is basically sine theta cos phi and this will be sine theta sine phi, and there is 0, plus we have y component 0 and I will be there. So I sine theta sine phi with the negative sign, and here I sine theta cos phi 0, plus I am using this space for this one. So we have cos theta 0, 0 minus cos theta. So this will be remain in diagonal. So you have this A vector or A operator. So don't write vector. This is not correct. This is A operator actually. Okay. So A operator is basically identified as, so diagonal term is basically cos theta minus cos theta. And what will be off diagonal term? You can take sine theta as a common. So here is sine theta, and you have cos phi minus I sine phi. So e to the power minus I phi. And here is sine theta e to the power I phi. So this is our matrix. Wonderful matrix you have. Okay. And when you are going to calculate the eigenvalue of this particular matrix, so let's try to calculate the eigenvalue. But before that, let us try to calculate what will happen to A square. Jara calculate karo to what will happen to A square. What will happen to A square? क्या मिल रहा है जरा देखिए तो. Anyone? So you have basically cos theta sine theta e to the power minus I phi, and you have sine theta minus cos theta, and sorry, e to the power I phi, and you have minus cos theta. इसको फिर से मल्टीप्लाई करोगे, you have cos theta sin theta e to the power minus I phi. क्या मिल रहा है ये?
Identity matrix.
Very good. You will get identity matrix. So what you will get, you will have, and if you will just going to calculate it, you will just go for identity matrix. So if you have this particular property, then we can make a norm. So if we have basically sigma dot n cap to the power n, and if this n is 2, or you can start with 0 also, 0, 2, 4, 6, all the even number, then this must be what? Identity. So it has to be identity. And you have another property, and the another property is basically you have sigma dot n cap is your another property, and this if you are just going for 1, 3 to the power n, and n is equal to 1, 3, 5 and so on, then this is equivalent to sigma dot n cap. So if you have even number of power, then you will always have identity, and because you know that this square is 1, this a square or sigma dot n cap square is 1, and then you can easily find that what is going to happen this one. Everyone is agreed up to this?
Yes.
है ना? So what you can do, you can just have a very nice property, and this property will very useful for you to you. ये जो आपकी property होगा, that is very useful to you, and a lot of problems in your exam is actually ask on to this particular property of Pauli spin matrices. So what you have a very nice character that sigma dot n cap n is equal to 1, or identity where n is even and sigma dot n cap to the power n is equal to sigma when n is odd. And then you can have one of the very nice property, and this property is basically if you have exponential, and you can write this thing as some I, a is some scalar, and you can write n cap dot sigma. If you want to write any operator, suppose there was lot of problem in which you have this sort of information is there. So if you have this sort of operator and there is n dot sigma, so what you can do? You can just do the Taylor expansion. Yes or no? आप इसका क्या करोगे? टेलर एक्सपेंशन करोगे? What will be this Taylor expansion? क्या होगा जरा बताइए?
1 plus
Summation over n is equal to 0 to infinity, and you have I a n cap dot sigma to the power n by factorial n, isn't it? Yes. And if you have this sort of information, then you can collect the odd term together and you can collect the even term together, and you will have a very nice thing, and that you will get identity cos of a plus you have n dot sigma sine of a with I cap, with I. So you can use this particular proof. You can easily do this thing. यहाँ इसके बाद हो जाएगा ना? कर लोगे या नहीं? Yes या no? Sorry?
सर यहाँ a क्या है? कांस्टेंट है?
A is some constant, some scalar. जैसे कि आप देखोगे कि भाई आपका कोई पार्टिकल है, स्पिन हाफ पार्टिकल है, वो मैग्नेटिक फील्ड से, कल हम इसके ऊपर प्रॉब्लम करेंगे तो आपको ज्यादा बेटर समझ में आएगा, वो मैग्नेटिक फील्ड के साथ इंटरेक्ट कर रहा है. सो वो मैग्नेटिक फील्ड का मैग्नीट्यूड होगा. आर यू गेटिंग माय पॉइंट? और पूरे मैग्नेटिक फील्ड को आप एक एन कैप के थ्रू लिख सकते हो. किसी भी वेक्टर को आप यूनिट वेक्टर बना सकते हो ना?
यस सर.
कैसे बना सकते हो? उसके मैग्नीट्यूड से डिवाइड करो, उसके मैग्नीट्यूड से मल्टीप्लाई करो. So आपका this a is some scalar number, where this a is a scalar number, and you can just do this Taylor expansion, है ना? और टेलर एक्सपेंशन करने के बाद आप क्या करोगे? ऑड वाले को सबको एक साथ लेकर जाओगे, ऑड वाले को सारे को एक साथ ले जाओगे, तो दिस विल बी सिग्मा डॉट एन कैप, है ना? नॉट सिग्मा, दैट इज सिग्मा डॉट एन कैप मिल जाएगा. इवन वाले को सारे एक साथ ले जाओगे, दैट विल बी आइडेंटिटी, and you will get this sort of information. Okay, so this is one of the very important identity that you have to use to solve different type of problems. Yes, कुछ बोल रहे थे?
सर सर कॉस साइन ए का पार्ट कैसे आएगा सर? वो एन का तो समझ आ गया, ऑड वाले टर्म्स में जो होएगा वो आइडेंटिटी होएगा फॉर द एन इज इवन एंड एन इज ऑड के लिए वो सिग्मा डॉट एन होएगा.
साइन का टेलर एक्सपेंशन होता है? साइन का टेलर एक्सपेंशन क्या होता है?
1 minus x plus x cube by 3 factorial
by x cube by 3, फिर
प्लस x5
x5
माइनस
तो x क्यूब बाई 3 को अगर x के जगह पर आप सिग्मा डॉट एन कैप लिखोगे तो वो क्या हो जाएगा? आप एक बार करके देख लो, आपको इतना परेशानी हो रहा है तो जस्ट राइट इट फर्स्ट टर्म क्या हो जाएगा? 1. व्हाट विल बी योर सेकेंड टर्म? I
Identity.
A n cap dot sigma by factorial by 1. What will be your second term? बताइए.
I square.
माइनस ना, तो दिस विल बी माइनस
A
आई स्क्वायर को
square.
-1 लिख सकते हैं.
Yes, sir.
यस. और n कैप डॉट आई को क्या लिखोगे? आइडेंटिटी.
Identity matrix.
आइडेंटिटी मैट्रिक्स A इंटू आइडेंटिटी बाई फैक्टोरियल 2. क्लियर है ये? नेक्स्ट.
Yes, sir.
नेक्स्ट बताइए क्या होगा, बोलिए. नेक्स्ट में प्लस या माइनस?
माइनस आएगा
माइनस आई आ जाएगा, है ना? तो यू हैव माइनस आई. ए फिर से क्या हो जाएगा? सिग्मा डॉट एन का होल क्यूब क्या आ जाएगा? एन कैप डॉट सिग्मा, दैट इज फैक्टोरियल 3. अब इंट्यूशन आ रहा है, एक और कर लें. अगला क्या होगा? आई टू द पावर 4 1, इजंट इट? आइडेंटिटी. यस या नो? बताओ.
Yes, sir.
आइडेंटिटी एंड ए टू द पावर 4, सॉरी यहां पर ए टू द पावर क्यूब, यहां पर सॉरी
A square.
ए स्क्वायर, सॉरी इस तरह ए टू द पावर 4. फिर क्या होगा? सिग्मा डॉट एन टू द पावर 4 इक्वल टू व्हाट? आइडेंटिटी. और यहां पर फैक्टोरियल 4. नाउ अब आप
माइनस आएगा ना सर?
हाँ,
नहीं सॉरी सर. कैसे होगा?
अल्टरनेट देख रहे हो? सिग्मा डॉट एन कैप आ रहा है. यस. और जहां सिग्मा डॉट एन कैप है वहां पर आप आई ले सकते हो. चलो इसको लेकर आते हैं. आई वाले टर्म को, इस टर्म को एक साथ लेकर जाओ. आई प्लस, सॉरी आई एंड दिस टर्म इज माइनस ए स्क्वायर आई बाई फैक्टोरियल 2 प्लस आई ए टू द पावर 4 फैक्टोरियल 4. सारे इवन वाले टर्म आ गए एक साथ.
Yes, sir.
चलिए, और आई देन यू हैव सिग्मा डॉट एन कैप, इसे कॉमन ले सकते हैं. यस या नो? एंड व्हाट यू हैव
Yes, sir.
इनसाइड? ए माइनस ए
A
क्यूब
cube
बाई फैक्टोरियल 3.
factorial 3
नेक्स्ट टर्म प्लस
plus
a5
A5 by
बाई फैक्टोरियल
factorial
5. व्हाट इज दिस थिंग? आई को कॉम बाहर ले जाओ. यू हैव
Cos
आई, और अंदर वाले टर्म का टेलर एक्सपेंशन क्या होगा? कॉस
cos
ए
A.
प्लस यहां बाहर क्या आ गया? आई सिग्मा डॉट एन कैप.
N cap
अंदर वाले को क्या लिखोगे?
sin A.
साइन ए. खुश? एक्चुअली मैं चाहता था ये आप खुद ट्राई करो. आर गेटिंग माई पॉइंट? हो गया? जिसने किसी ने तो पूछा था ना अभी.
यस सर.
खुश हो गए? चलो आपको खुद भी ट्राई करना है ना? सो ये प्रॉपर्टी आप बहुत जगह यूज कर सकते हो. जहां भी टेलर एक्सपेंशन आएगा तो आप इस प्रॉपर्टी को यूज कर सकते हो ना भाई. किसी भी फंक्शन का अगर सिग्मा डॉट एन कैप किसी भी फंक्शन का लें और अगर हम उसका टेलर एक्सपेंशन करें तो ये टर्म तो टेलर एक्सपेंशन में क्या होगा? पॉलिनोमियल्स ही तो होते हैं. 1 का पावर, 2 का पावर, 3 का पावर, इजंट इट? and you can have this sort of information. So this is one of the very interesting property of basically Pauli spin matrices. And now let's try to calculate the eigen value of sigma dot n cap. पूरी की पूरी आज कहानी हम सिग्मा डॉट एन कैप के अराउंड रख रहे हैं. तो आपको ये सारी प्रॉपर्टी दिमाग में रखनी होगी, है ना? और कैसे कैलकुलेशन करना है आपको पूरी तरह से समझना होगा. ओके, सो लेट्स ट्राई टू गो फॉर द आइगन वैल्यू ऑफ sigma dot n cap. So you have a operator, and this operator is sigma dot n cap. So if this is your a operator, and which is basically you have cos theta, and here is sin theta e to the power minus I phi, and you have basically sin theta e to the power I phi, and you have minus cos theta. Can any guess what should be the eigenvalue? Any guess? So this is again traceless matrix. So जो प्लस में होगा वो माइनस में भी होगा. Yes? 2 क्रॉस 2 मैट्रिक्स है, तो दिस इज योर ट्रेसलेस मैट्रिक्स. तो जो प्लस में मिलेगा वही माइनस में भी मिलेगा. यस या नो? And if you will see, this matrix is also a unitary in nature. So what should be the eigenvalue? क्या eigenvalue होना चाहिए? बताओ. What is eigenvalue of unitary matrix?
Plus minus 1.
Plus 1 and minus 1. And now we will check it. So you can easily calculate cos theta minus lambda sin theta e to the power minus I phi sin theta e to the power I phi minus cos theta minus lambda. And this must be equal to 0. So you can have minus sign, you can take common. Cos square theta minus lambda square. इनको मल्टीप्लाई करेंगे तो होगा ना?
हाँ सर आ रहा है.
आ रहा है. वेरी गुड. सो माइनस इन दोनों को मल्टीप्लाई करोगे तो क्या होगा? साइन थीटा साइन स्क्वायर थीटा, ये दोनों एक दूसरे को कैंसिल कर देगा. सो यू हैव साइन स्क्वायर थीटा, तो थीटा लिखना भूल गया मैं. दिस वैल्यू इज इक्वल टू 0. सो यू हैव माइनस कॉस स्क्वायर थीटा माइनस माइनस प्लस लैम्डा स्क्वायर माइनस साइन स्क्वायर थीटा, दैट मस्ट बी इक्वल टू 0. सो लैम्डा इज इक्वल टू plus minus 1. Yes? So your eigenvalue of this matrix is plus minus 1. So now can you please tell me what should be the eigenvalue of S dot n cap? And S is the spin matrix or spin vector for spin half particle. What should be S dot n cap? प्लीज क्या होगा? अगर इसकी आइगन वैल्यू प्लस माइनस 1 है तो इसकी आइगन वैल्यू क्या होगी? व्हाट इज एस वेक्टर? एस वेक्टर इज नथिंग बट h cut by 2 sigma dot n cap, isn't it? So what will be eigenvalue for this particular operator? You have h cut by 2 and minus h cut by 2. So you have h cut by 2 and minus h cut by 2. So you have this particular thing. Now on to basis of this intuition, if I will ask you, there is a operator and you have L dot n cap. For the L is equal to 1, what should be the eigenvalue of this operator?
टू एच क्रॉस स्क्वायर.
कंचन सोच कर आंसर दो.
रूट टू एच क्रॉस.
कंचन सोच के आंसर दो. What will be the eigenvalue of this one? ये किसका आइगन वैल्यू है? एस स्क्वायर का आइगन वैल्यू या एस जेड का आइगन वैल्यू है? this is that what will be the eigen value? S स्क्वायर का है या SZ का है? SZ का है. सो यहां पर भी जो आइगन वैल्यू होगा वो किसका आइगन वैल्यू मिलेगा आपको? LZ. So for L is equal to 1, what is the value of possible quantum number for LZ? हाँ? क्या है? बिल्कुल नहीं पढ़ते हो एकदम यार. क्वांटम मैकेनिक्स करने के लिए थोड़ा पढ़ना पड़ता है ना. फॉर L is equal to 1, what is the eigen value associated to LZ? What are the possible eigen value?
-1 0 1
0
हाँ, क्या बोल रहे हो?
0 H cross
वेरी गुड. 0 H कट एंड माइनस H कट. क्या कर रहे हो भाई? L is equal to 1 के लिए M की वैल्यू क्या क्या पॉसिबल है? 0 +1 एंड -1. So what should be eigen value for this matrix from this intuition, from this analogy? The algebra is exactly same. So if algebra is exactly same, then you can use the eigen value of this one is 1 0 -1. This will be your eigen value. So if you have any operator in as a function of Lx or L, if you can write the thing in term of L dot n cap, you can easily find the eigenvalue. Are you getting this thing? And now let's try to calculate what will be the eigenvector. Okay, so let's try to calculate the value of eigenvector for lambda is equal to +1 and lambda is equal to -1. Clear है ये? चलो. So you have suppose lambda is equal to 1. 1 के लिए मैं निकालता हूं, -1 के लिए आप एज ए होमवर्क लिख लेना. I will just directly write it. Okay. So lambda is equal to 1 के लिए आइगन वैल्यू आइगन वेक्टर निकालना चाह रहे हैं. So we have cos theta, sin theta, e to the power -i5, sin theta, e to the power i5 minus cos theta. And we have A and B, and we have to calculate the normalized eigenvector. Okay. And this value is equal to 1, A and B. And when you are going to multiply this thing, so you have A cos theta plus B sin theta e to the power -i5 is equal to A. लिख सकते हैं इसे? And you can take A together. So you have B sin theta e to the power -i5 is equal to A 1 minus cos theta. We can write it in some better way. So आप इसे कैसे लिख सकते हो? sin theta को B 2 टाइम sin theta by 2 cos theta by 2 is equal to A. इसे क्या लिख सकते हो आप? 1 minus cos theta को थीटा बाई 2 के टर्म में लिख सकते हैं?
2 sin square theta by 2
2 sin स्क्वायर या cos स्क्वायर?
minus
So what is your cos square 2 theta? Sorry, cos 2 theta is cos square theta minus sin square theta. तो हमें cos रखना है ना, so cos theta रखना है. So इसको मैं क्या कर सकता हूं? Cos, so I can write this will be 1 minus sin square theta minus sin square theta. So this is 1 minus 2 sin square theta, है ना? सो इसको जब आप इधर ले जाओगे तो क्या हो जाएगा, -1 आएगा ना। तो अगर इसको कॉस के टर्म में लिखोगे तो क्या होगा, इसको कॉस के टर्म में भी लिख सकते हैं, यस या नो। यू कैन
थीटा
राइट,
इज इक्वल टू 2 cos थीटा।
ऐसा भी लिख सकते हो इसको। आप साइन के टर्म के जगह पर कॉस के टर्म में लिखो तो क्या हो जाएगा, कॉस स्क्वायर थीटा -1 माइनस कॉस स्क्वायर थीटा, क्या हो जाएगा ये। सो दिस इज 2 कॉस स्क्वायर थीटा -1, ठीक है ना। सो 1 माइनस कॉस थीटा को कैसे लिख सकते हैं, कौन सा यूज करना होगा हमें, दिस वन ना। सो यू हैव हाँ, cos 2 थीटा -1 इज इक्वल टू 2 साइन स्क्वायर थीटा माइनस साइन, ठीक है ना। सो माइनस हो जाएगा तो यस, सो 2 साइन स्क्वायर थीटा इज देयर, क्लियर है ये, क्या होगा ये 2 साइन स्क्वायर थीटा। सो यू हैव 2 साइन स्क्वायर थीटा बाई 2. So this 2 and this 2 is cancelled, and you have this sin theta by 2, this sin theta by 2 is cancelled. So what you can write? You can write b is equal to something like, and ये भी रहेगा ना, this part is also there. So this thing is also there. So e to the power I phi इधर ले लो. So b is equal to a, that is tan theta by 2, है ना, a tan theta by 2 e to the power I phi. So you can write, so this is my vector a को a ही रहने देते हैं, and this will be tan theta by 2 e to the power I phi, and a is also there. So now we have to calculate the value of a, ठीक है। So you have to calculate the value of a such that this is normalized. एग्जाम में आएगा, 100% आएगा इसके ऊपर क्वेश्चन, क्योंकि ट्रेंड शुरू हो गया है गेट के एग्जाम से, ओके। So always try to, so what will happen? So you have a tan theta by 2 e to the power minus I phi, और ये क्या हो जाएगा, a, sorry क्या लिख दिया मैंने, a is also there, a is also there. So a and a tan theta by 2 e to the power I phi, this must be equal to 1. क्या हो जाएगा, a स्क्वायर कॉमन ले लो, e to the power I phi और e to the power minus I phi, this will be cancel. So a square 1 plus tan square theta by 2 is equal to 1. So what is value of a?
A square is equal to cos square theta by 2.
A square or a is equal to
Cos theta by 2.
Cos theta by 2. So we can put a is equal to cos theta by 2. So now we can put it here, a is equal to cos theta by 2. So what will be value? So this will be cos theta by 2 and sin theta by 2 e to the power I phi. If I am not wrong, this is your normalized. Huh?
B is tan theta by 2, na? A tan theta by 2 I phi.
Sorry? a को यहाँ पुट करो ना, अरे a को तो यहाँ पुट करोगे तो tan थीटा बाई 2 तो sin थीटा बाई 2 प्लस बाई cos थीटा बाई 2, तो cos थीटा कैंसिल नहीं हो जाएगा। हाँ, so yes, this is your eigen vector. Okay, now this is your homework that you have to calculate the eigen vector for lambda is equal to -1. कर पाओगे इसे? Just post me as your homework. ठीक है, सेम चीज आ जाएगा बट थोड़ा सा चेंजेस आएंगे चीजों में। ओके, सो दिस इज योर आइगन वेक्टर फॉर लैम्डा इज इक्वल टू 1। बिकॉज ये आइगन वेक्टर आपको इसलिए याद रखना होगा क्योंकि एग्जाम में वो डिफरेंट एंगल पर चीजें पूछेंगे। यू कैन इजिली पुट थीटा बाई 2, थीटा की वैल्यू पुट करो, फाई की वैल्यू पुट करो एंड यू विल गेट द आंसर, है ना। सो फास्ट करने के लिए ये चीजें आपको एक बार जरूर कर लेनी चाहिए। एंड द लास्ट प्रॉपर्टी ऑफ दिस पॉली स्पिन matrices is, this is also very nice property, और इसका भी हम यूज करेंगे जब भी आपको जरूरत पड़े तो. So this property is very nice. If we have some vector A, this is constant vector, and some vector A is there, so A vector dot sigma into B vector dot sigma, अगर ऐसा हमें मिलता है, so this is some another matrix, this is some another matrix, you can have this two matrix and you have the product of this matrix. So this value is very interestingly known as, so you have A dot B into identity matrix plus I A cross B into sigma. So this is one more identity that you have to remember, और इसका हम use करेंगे different types of problem को लेकर के, ठीक है? So this identity is also important. And you can have also check that all the component of Pauli spin matrices, you have sigma x square is equal to sigma y square is equal to sigma z square is equal to identity. So this is your identity matrix. So you have to always take care of this information also. Okay. So, and obviously, what will be sigma cube? Sigma x cube की वैल्यू क्या हो जाएगी? Is again sigma x. है ना? So you have this kind of situation. So ये सारी property आपको अपने दिमाग में रखनी होगी, and then we can solve different types of problems. Okay. So next class में हम लोग problem solve करेंगे. But before that, try to do all this thing with yourself, और फिर postulates को करके आइएगा. ठीक है? We have to use postulates because without postulates तो कुछ भी नहीं हो सकता है ना? So I will stop this class here. Next class में हम लोग problem solve करेंगे. Most probably it will take one class or two class. We will solve different types of problem. Okay. And after doing Pauli spin matrix, we will take a pause, and first we will complete all the test, and then we will go for next level of analysis. Okay. Radial wave function and then approximation method. Clear है? So your quantum mechanics is going to next level, है ना? Next level में hydrogen atom करने के बाद हम लोग final level पहुंचेंगे. ठीक है? Where you will use approximation method. But approximation method में आप वही तभी अच्छा कर पाओगे जब आप पहले की सारी चीजें बहुत ही अच्छे से कर लो. And आपकी performance को देखकर लग रहा है you really need a long session of revision. Okay? चलो. Thank you.